This problem is a motion problem. It states that the current in a stream moves at a speed of 2 kilometers per hour. A boat travels 44 kilometers upstream and 52 kilometers downstream in a total of 4 hours. What is the speed of the boat in still water? Our first step will be to familiarize ourselves with the problem. That could involve rereading it. And whenever we have a motion problem, we're looking at 3 quantities: distance, speed, and time. So let's look at the problem before we write anything down and see what we know about the distance. We notice that the boat travels 44 kilometers upstream and 52 kilometers downstream. The distances are different for both of those, but they're given. The time we see is a total. We don't know how much time was traveled upstream or downstream, but those times should add to 4 hours. And as far as speed goes, we're given the speed of the current and we're asked to find the speed of the boat. So we're going to have to know how the speed of the boat with the current and against the current will be, how that will work together. So when we move to our familiarize step, we'll begin writing by assigning a variable. We're asked to find the speed of the boat in still water. So let's let that be r. And I'm going to spell out exactly what I'm looking for, what I'm letting it equal. R is the speed of the boat in still water. And then what will the speed be going with the current? Well, with the current will push the boat along. The speeds are actually added. With the current, the speed will be r plus 2, and that would be downstream. And then against the current, the speed would be r minus 2. That's the speed of the boat minus the speed of the current, and that would be going upstream. Now, whenever we have a motion problem, we should organize our information in a table. The columns of the table can be distance, speed, and time. And the rows can be the different motion situations we're looking at. In this case, we can call them upstream and downstream. And that gives us 2 rows to fill out and 3 columns in each row. And what I like to do is fill in the numbers that I know to start with. I know the distance upstream, and I might need to look back at the problem. 44 kilometers upstream, 52 kilometers downstream. So I can fill this in with 44 and 52. Now, I've also, in my familiarize step, realized or worked out that the speed with the current downstream was r plus 2, and the speed upstream was r minus 2. I don't know the times. At this point, I'm just going to label them t, and I'm going to use some subscripts because I want to make sure they're both times. And I'm going to call one t sub 1, that means time 1, and t sub 2, time 2. And I remember that these times are a total of 4 hours. Well, I can move to the translate step next. And in the translate step, I'm going to use the equation distance equals rate times time, or I'm going to use actually time equals distance divided by rate, because I'm going to want to add the times together to get 4 hours. So my next step will be to translate. And I translate each row of the table. The first time, I'm going to use time equals distance divided by the rate or the speed. The first time, or the time upstream, is the distance upstream divided by the rate upstream. The second time, the time downstream, is the distance downstream divided by the speed or the rate downstream. Now, the key to the translation is that these times add to 4 hours. So I can write 44 over r minus 2 plus 52 over r plus 2 equals 4. When I've done this, I now have an equation with just one variable, r, and I can solve that for r.